All right, so we're going to get started. Tonight's topic is all about particle motion, which is almost always a free response question on the exam. It also will definitely be in your multiple choice. It's one of the most everyday applications of calculus that we see. And so we're going to start by looking at what some of the relationships are, and then from there we're going to go into some example problems in the three main categories, which are just evaluating, optimizing, and accumulating. Those are really our three big ideas tonight. So we're going to start with the general overview. So first of all, we're talking about an object moving along a straight line when I talk about particle motion. So when I talk about an object moving, I'm saying that's my object. And basically what I'm saying is this object is just moving back and forth along a straight line. It doesn't have a lot of options as far as what it can do. So basically what this object can do, if that's its straight line, is it can move to the right, to the left. It can stay still, it can speed up, it can slow down, it can accelerate in one or the other direction. We're going to typically define to our right as positive, to our left as negative. So a couple things. Number one, average velocity or average acceleration, whatever your average is. We're talking about the change in whatever the previous quantity was over the change in time. So average velocity is the change in position over the change in time. Average acceleration would be your change in velocity over change in time. If you're given velocity and asked about average velocity, that's going to be a little different, and we'll look at that later tonight too. Instantaneous velocity, anytime I talk about instantaneous, now I'm talking about the exact velocity at an exact point. And so instead of talking about the slope of the secant line, which is what this is, here I'm talking about the slope of the tangent line. And so we would say that velocity is the instantaneous rate of change of position, acceleration is the instantaneous rate of change of velocity, jerk is the instantaneous rate of change of acceleration, and so on. Speed, this is going to be a really important distinction tonight. Speed is the absolute value of velocity. Velocity is a vector. Speed is a scalar value. So speed does not have a direction, whereas velocity can have a direction. So keep that in mind if that's something we get stuck on, and we'll talk more about that. We know that acceleration is the derivative of velocity. This is a really important thing. If you are going to talk about acceleration, if you're going to tell me A of t equals, and you're given v, you need to define this relationship. And we'll talk a little bit more about that tonight too. Since these are derivatives of each other, we can also say that they're related via antiderivatives. So the antiderivative of velocity is position plus a constant. The antiderivative acceleration is velocity plus a constant. Total distance traveled, there are really two ways that you can figure this out. The easiest way is to take the integral of the absolute value of velocity, because that's going to take, let's say this is your velocity function, and it's going to take any negative parts, like this part right here, and it's going to reflect them over. And so you will only be getting positive accumulations there. So that's really what we're doing. There's some other ways you can do it depending on what information you're given. We'll talk about that all more later tonight. I want to get a little bit more into the speed versus velocity thing. And again, this whole document is on my teacher site, so go grab it if you want it. So if velocity and acceleration have the same sign, then speed is increasing. And that's because if this is my little Paul the particle, if he is moving in this direction and accelerating in that direction, he's going to speed up. But if he's moving in this direction and his acceleration is going the opposite way, he's actually going to wind up slowing down, because there is no such thing as decelerating. Decelerating is a result of accelerating the opposite direction. So that's something you just need to be mindful of. Anytime your signs match, either both positive or both negative, speed will increase. If they don't match, speed will decrease. So let's look at this graph. I want to kind of take a look at this. So this is a graph of velocity. They tell me that. So I'm going to make a sign chart here for my velocity. This is v of t. So I see it has zeros at 2 and at 5. Before 2, it is positive. After 2, it's negative, and then it's positive again. So that's my sign chart for velocity. I'm going to throw on this the values for v prime of t, which is a of t. And notice I'm not just calling it a of t, because a of t doesn't mean anything unless I define it in terms of v here. So, okay, let's look at my slope of velocity. So here, velocity is sloping downward until 4, so that's negative. Here, it's sloping upward after that. So again, when I look at the derivative, I'm looking at the slope. So what I'm saying here is that I want my signs to match for it to be speeding up. So right here, this is positive, and acceleration is negative. So there, it would be slowing down. Here, 2 to 4, that's negative, and that's negative. So that would be an interval where they speed up. Here, that's negative, and that's positive. That would be a slowing down interval. And here, that's positive, and that's positive. So anywhere that your signs match, those are your intervals where you're speeding up. This is a little bit more analysis on that. Anytime that your signs are different, you're going to be slowing down. Anytime that your signs are the same, you're going to be speeding up. So that's something that we're going to talk about a little bit more tonight too. These are the big things that you need to know. When you see initially, think when time equals 0, not when the x value is 0, when time is 0. If you see at rest, that means your velocity is 0. If you see at the origin, that means your position is 0. Okay, so these are different types of zeros. If you see velocity is positive, particles moving to the right or up, velocity is negative, moving down or left. Average velocity, given the position, you're going to do change in position over time. Average velocity, given the velocity, now I'm actually asking you for average value. So I would use the average value formula here, which looks like that. The instantaneous velocity is the velocity at the exact moment that typically is asking you for a derivative. Positive acceleration is an increasing velocity. Negative acceleration is a decreasing. Speed is the absolute value of velocity. And total distance is your total accumulation of the absolute value of velocity. So we're going to start with some just straight up evaluation ones, and then we'll get into some that are a little bit more difficult. Some of these are calculator active, some are inactive. The most important thing I can tell you guys is on calculator active, please use your calculator, right? Use it. You have it. Most of the time, the derivatives are going to be so time consuming, it's not going to be worth your time to do it by hand. So, a particle is moving along the straight line with velocity. So I'm given velocity. What is the acceleration at t equals 3? I'm going to treat this like it is a free response. Okay? So I don't want to write this. I don't want to write a of 3 equals because that's not a thing. That's not defined here. I have v. So I can only say a of 3 if I define that as v prime of 3. As long as you have that connection made, you're fine. And now I'm going to say what that equals. Now, this is where this is your friend. So I'm turning this on. I'm going to math, and then I'm going to 8, which is n deriv. I'm sure that's backwards for you. And it's going to bring up that blank screen, right? Where you can put in your x, put in your function, put in your x value. So I already did this one up here. So put in all those, evaluated it at x equals 3. I hit enter, and that gives me 0.545. So 0.545. 0.0545, sorry. They're never going to give you one where it's a difference of like 1/1000th, because remember that you can always round or truncate. So this would be B. All right, let's go a little further. So a particle moves along the x-axis. So again, we're just moving left and right. Its position is given by this. When is the particle at rest? So when I see particle at rest, I think that means velocity equals 0. In the case of what I have here, we started with x, right? That's our position. So what I need is for x prime of t to equal 0. Again, I know that's v of t, but if I'm going to say that, I need to define it specifically. So let's look at this function. This would be x prime 6t squared minus 42t plus 72. We want that to equal 0, so I'm going to factor out a 6. T squared minus 7t plus 72 divided by 6 is 12. Yeah. So that's going to give me 6, and then t minus 3, t minus 4, So t equals 3, t equals 4. So those are my times when the velocity equals 0. Those are both on my interval because all I care about is that it's greater than 0. And so this would be my answer. Again, just evaluating. Okay, send questions if you have them. Next one, the velocity of a particle moving along the x-axis is given by the function v of t. Notice we're given velocity. I want the average velocity. So you have two options with average velocity. Either you're going to be finding your change in position over time, or you're going to be finding the average value of velocity. It depends what you're given. In this case, I was given velocity, so I need to find the average value of velocity. So you need to be discriminating about what you're given. Remember, average value is 1 over b minus a, the integral from a to b, of f of t dt. That's our formula typically. So it'd be 1 over b minus a is 3 minus 0, the integral from 0 to 3 of v of t dt. This is one you could just throw in your calculator, and at the risk of boring you tremendously, I'm going to put in my fraction first. So I put in alpha y equals 1 over 3. So I'm putting that in. And then you can put your integral right after that, so math 9, the integral from 0 to 3 of v of t, so e to the x, on my calculator I have to put an x, plus t, or x, e to the x, dx. And make sure when you do x, of course, you're using the x button. That's what I'm putting in. I hit enter, and I get 20.0855. So that is A. Okay. Next one. So two runners, A and B, are on a straight racetrack from 0 to 10. The graph above shows, which is 2 line segments, shows the velocity of runner S is runner A. This is VA. The velocity of runner B is this. Find the acceleration of runner A and the acceleration of runner B at t equals 2. Indicate units of measure. So if I'm saying acceleration, what I'm saying is I want v prime of t, right? I want the velocity of t. So to find that for runner A, I would look at the graph. I would say, okay, at 2, what is the derivative there? Derivative being slope. So your acceleration here is the slope there, which is 10 over 3. Let's think about our units. This is in meters per second. This is in seconds, so it's meters per second squared. Now let's look at this puppy. So to find this one, I need to find v prime. So v prime of t is low, d high, minus high, d low, which is just 2, over low squared. And I want that at 2, so I would plug in 2 there. So this would be 4 plus 3 times 24 minus 48 times 2, all over 4 plus 3 squared. Leave it alone, unless you have a calculator. Even so, leave it alone. And we're talking about the same units because this is meters per second, and we're talking about seconds. So this is meters per second squared. So this is the velocity of runner B, or acceleration, sorry. Okay, so those are the basics of kind of calculating things, right? Just calculating. Now what we're going to start to look at is some accumulating. So what do I do when I'm working the other way? So on this first one that says number 7, a particle moves along the x-axis, again, just left to right, with a velocity given by this. If the particle is at a position x equals 2 at t equals 0, boom. In my mind, that screams initial. Okay, that screams initial. What is the position of the particle at t equals 1? So I'm given velocity, I want the position. I need to go backwards. And automatically, what I'm thinking here, besides that I couldn't say automatically, is that I'm going to do the initial plus the net change in position. So my initial here is 2. Plus, The net change in position is going to be the integral from 0 to 1, because we want to know the position at 1, of v of t, which is 3t squared plus 6t dt. This is a non-calculator. It was number 7 on an exam. So I'm actually going to integrate this. So this would be t cubed plus 3t squared, evaluated from 0 to 1. So that gives me 2 plus 1 plus 3 minus 0. So that is 6 is my position. So this would be B. All right, continue to send questions. Next one, object traveling along a straight line. Initial position, they didn't hide that one, is 2. This is velocity. What is the position at 3? Again, initial plus net change. So my initial is 2. My net change, I'm going from 0 to 3 of v of t. I will tell you this was a calculator one, so I'm just going to throw this in my calculator. So I would do 2 plus the integral, math 9, from 0 to 3 of, and then plug that in. The cube root is under math, 1 plus x squared dx. So here's what I'm plugging in. Hit enter. And when I plug that in, I put 0.2, so don't do that. It's very hard to show you guys the calculator on the computer. All right, so I got 6.5115, which would be D. And notice the one that's below it is right there, glaring at you, waiting for you to pick it. Okay, next one. A particle moves along the x-axis. Its acceleration is given by this. If the velocity is 2 at time equals 1, what is the velocity at t equals 2? Initial plus net change. So your initial is 2. All of these were 2. Our net change is going to be the integral, and notice where we started now. We started at 1. So this is the integral from 1 to 2 of a of t dt. I'm going to put that into my calculator. I know this is boring, so speed me up through this if you need to. Math 9, integral from 1 to 2 of ln 1 plus 2 to the x dx. So that's what I'm putting in there. Hit enter, and I get 3.346, which is E. Okay, cool. Now, a good bet on this is they will have one where it's the integral from 1 to 2. So just be careful. All right, next one. So I've got this table. Johanna is jogging along a straight path from 0 to 40. Her velocity is given. So that's velocity. Here, it's measured in minutes, and V is in meters per minute. So units are going to matter here. So part A says use the data from the table to estimate V prime of 16. Notice it does not say A of 16 because A is not a thing. It's not defined. We need V prime. So V prime of 16, what I would do is I would say, okay, 16's in between those. So I'm going to find the rate of change between those. So V prime at 16 is approximately, and you have to show your setup here. So I would say V of 20 minus V of 12 over 20 minus 12. You cannot just leave it there. It has to be all numbers. So this is going to be 240 minus 200 over 20 minus 12. It doesn't say indicate units of measure there, but let's do it just to be safe so we know we have it. V prime of 16 would be in meters per minute squared. And it can stay in that form. Totally fine. All right, part B says, using correct units, explain the meaning of the definite integral. The integral from 0 to 40 of absolute value of V of t, approximate it using a right Riemann sum with 4 subintervals. So let's take a look at that. So let's start with the Riemann sum, and then we'll talk about the integral. So B, to find this Riemann sum, notice that I've got a negative value here, and I want the absolute value. So when I do this Riemann sum, I'm just going to pretend that that's a positive 220. That's all I'm going to do. Treat it like it's absolute value. I have 4 subintervals, 0 to 12, 12 to 20, 20 to 24, and 24 to 40. And I'm doing a right Riemann, so I'm using the right hand point on each interval. So this is going to be 12 times 200, that's my first one, that's this, right? The width is 12. Plus, from 12 to 20 is 8 times 240, plus, from 20 to 24 is 4 times 220, again, absolute value, because we're talking about the integral of the absolute value, plus 16, the integral of 150. So that is my sum. You do not need to simplify it. Please don't simplify it. What does this mean with correct units? Well, when I integrate velocity, I normally get displacement, right? My net change in position. When I integrate the absolute value of velocity, I get my total distance traveled, because I'm not taking into account whether I was going in a positive or negative direction. So this, the integral from 0 to 40 of the absolute value of v of t dt, represents, and you want to be as specific with this as possible, the total distance traveled, and I would even go back to the question, the total distance Johanna jogged. You say that name however you want. Okay, total distance she jogged from 0 to 40 minutes. From 0 to 40 minutes. Or you could say over the 40 minutes described. And then with units in meters. And that is what you would need to get full credit for that. Now the next part of this question was like an MVT, and so we could go from there. But please continue to send questions as you have them. I'm just going to check the chats really quick. Okay, we're good. So let's move on. Let's look at this next one. So this one says calculate the total distance traveled, and you can't read that. There we go. Calculate the total distance traveled. So start with, what if I have a calculator? Because if you have a calculator, this is really, really easy. We're going from 0 to 3. If you are calculating the total distance traveled, you could find the position at a bunch of different places. Actually, this is pretty much the same with or without a calculator. So this is position, right? And I want to know what the total distance traveled is. I can't just find where it starts and where it ends. All that would give me is displacement. So what I need to find is where it changes position, and then I can go from there. So this, to find where it changes position, I'm going to take the derivative, which would be 6t minus t squared. I'm going to set that equal to 0. And I will tell you this equals 0 at t equals 0 and at t equals 6. So I know that there is a position change at 0 and at 6, which actually isn't on my interval. So that doesn't really matter much. So this is a pre-calc question, and I should not have snipped it. You could find the initial position, the final position, and just subtract them. Yeah, okay. All right, let's talk about speed a little bit. Let's talk about speed. So for speed, remember, speed has to do with whether your derivative or your acceleration and velocity have the same sign. That's what speed has to do with. Do acceleration and velocity have the same sign? So this is my curve. Okay, from 0 to 12, a particle moves along the x-axis, just left to right. The velocity is given by this. So the first thing I want to know is, when is the particle moving to the left? So to find that, what this makes me think is that v of t is a negative. It's less than 0. So I'm going to take v of t. I'm going to set this equal to 0. And let's think about how we would solve this, because you would not have a calculator for something like this. So what you need to know is, where does cosine equal 0? Think about your unit circle. Cosine is 0 at pi over 2. And cosine is 0 at 3 pi over 2. Right? So those would be my values, every multiple of that. So what I want to know is, well, what values of t is this happening at? So let's take a look. So pi over 6t has to equal, let's say, pi over 2, right? Or 3 pi over 2. So let's kind of go from there. So this would give me that t equals, multiply by 6 over pi, 3. That's one possibility. Now, pi over 6t could also equal, what else? Could also equal 3 pi over 2, which would give me 9. And we can try another value. Let's see. I'm just trying to shrink these down. It could also be 5 pi over 2. So pi over 6 could equal 5 pi over 2. And that would give me that this is 15. So that's out of my interval, so I don't need to worry about that. So the t values I'm going to look at are at t equals 3 and t equals 9. Okay, t equals 3 and t equals 9. Actually, let me not erase those so they're there if we need them. So t equals 3 and 9. So looking at my sign chart, I'm going to put 3 and 9 on there. And I need to test this. So let's test a number less than 3. I'm going to pick 1. So if I plug in 1, I get cos of pi over 6, which is a positive. If I plug in 4, I get cosine of 2 pi over 3, which is negative. If I plug in 10, I get cosine of 5 pi over 3, which is positive. So that's my chart. So this would be moving to the left, moving left on 3 to 9, because v of t is less than 0 on this interval. All right, let's find the acceleration at time t. That means find v prime of t. So derivative of cosine is negative sine. Leave the inside alone. Times the derivative of the inside, which is just pi over 6. So that's that. The last part is the speed increasing, decreasing, or neither at 4. So let's look at it. We already said for velocity, 4 is in this interval. So this is a negative velocity. So v of 4 is less than 0. I know that. So let's find v prime of 4. So a of 4, which I would define as v prime of 4, equals negative sine of pi over 6 times 4 is 2 pi over 3 times pi over 6. Sine in the second quadrant is positive, so this comes out to be less than 0. So this is negative. Since I see that my velocity is negative and my acceleration is negative, this would be speeding up. The particle is speeding up. Because v of 4 and v prime of 4 have the same sign. Okay. Send any questions that you guys have. Oops, flip my iPad. Send questions that you guys have on that. I'm launching my iPad on the floor. And I'm going to give it a second, and then we'll go from there. So again, if you have questions, let me know. Otherwise, we're going to move on to the next. Okay, next one. This is from last year's exam. So this is actually from last year's exam. So we're going to take a look at this pretty closely because this is very close to what you could actually see. So here's what it says. I want to know, first of all, when I have two particles. For particle P, this is its position. For particle Q, this is its velocity. So notice they're giving me different information about them. One, they're giving me position. One, they're giving me velocity, right? So I need to be careful with that. So at particle Q starts at position x equals 5, initial amount. So from 0 to 8, when is P moving to the left? Moving to the left would mean V of T is negative. And I want to find this out for particle P. So what I'm going to do is I'm going to find my derivative of that. So derivative of ln is 1 over that thing. So 1 over t squared minus 2t plus 10 times the derivative of the inside, which is 2t minus 2, right? And, I mean, I can factor that a little. That's going to be 2t minus 1 over the denominator. Doesn't really give me anything nice to factor. T squared minus 2t plus 10. So that's my derivative. So I'm looking at when this is negative. The denominator is always going to be positive for any value greater than 0. But my numerator is negative. If you think about this, this is negative anywhere between 0, where we start, and 1. So it's negative here, and then it goes to positive. So what I would say is the particle is moving left. The particle is moving left on the interval from 0 to 1. So this answer would be 0 to 1. Okay, that answer would be 0 to 1. All right, find all times during which the two particles travel in the same direction. So I already know for this one, it's traveling to the left here and then to the right everywhere else. So let me organize this a little bit better. So let's do particle 1, or particle P, and particle Q. So for P, I know from 0 to 1, it's moving to the left and then to the right. For particle Q, they give me this velocity function. So I'm actually going to find the zeros of that. So the zeros of that, this would be t minus 5, t minus 3. So my zeros are at 3 and 5. And I want to start at 0 because that's where my interval starts. So this is going to be moving to the right, to the left, and to the right if we do sign analysis. I want to know where they're moving in the same direction. So that's what I'm looking for here. So this one, it's almost helpful to put them all on one chart. So if I do from 0 to 1, 2, 3, 4, 5. So particle P is moving to the left from 0 to 1, and then to the right everywhere after. Particle Q is moving to the, let's pick a different color, right from 0 to 3, and then to the left from 3 to 5, and then to the right everywhere after. So let's look at where this is happening, and our interval only goes to 8, so that's something to note. So where are they moving the same direction? So definitely between 1 and 3, they're both moving right. And between 5 and 8, they're both moving right. So my answer to part B would be, when are they traveling in the same direction? From 1 to 3 and from 5 to 8. And what they wanted to see there was that they have the analysis. Okay, so I would say this because x prime of xp prime of t and vq of t have the same sign. Okay, next one. Find the acceleration of particle Q at 2. Is it speeding up, slowing down, or neither at t equals 2? Explain. So for this to be true, we need velocity and acceleration to have the same sign. So let's think about this. The velocity at 2, so we already said here, velocity at 2, that's going to be in here. It's moving to the right. It's positive. So this VQ of t is positive, and not of t actually, of 2. And now I want V prime Q of 2. So V is this, V prime is t squared, or v prime is 2t minus 8. So if I plug this in here, this is less than 0, right? It comes out to be negative. And so because these have different signs, because my velocity has one sign, my acceleration has the other, I could say that the speed is decreasing because vq of 2 and v prime q of 2 have different signs. Again, send questions as you have them. All right, and then it says, what is the position of particle Q the first time it changes direction? So I'm going to look back at my sign chart. The first time it changes direction is at 3. So I want the position at 3. So anytime we're doing this, I'm going to think initial plus net change. They told me up here my initial was 5. So it's going to be 5 plus my net change from 0 to 3 of VQ of t dt. Just to integrate that, it's power rule. I will tell you that that comes out to be 5 plus, this is going to be 9 minus 36 plus 45, and that would give you 23. All right, what questions can I answer on that? All right, the next two questions are almost identical to that, so we're not going to do both of those. If you have questions at the end, we can come back to these, but we're not going to do both of those right now. So last thing we're going to talk about is optimizing with this, and that is finding maximums, finding minimums, finding most, finding least. So they might give you something like this, where they say the velocity of a particle is this. When is the particle farthest to the left? When is the particle furthest to the right? So here's what I want you guys to think about. Farthest to the left is really saying what is the minimum position, right? What's the minimum position here? And if they don't tell me an initial value, I'm going to assume my initial value is 0. So I want to minimize position. So first of all, let's look at when it changes directions, okay? So this is my velocity function. So I'm going to set that equal to 0. So t cubed minus 6t squared. I'm going to factor out t squared, t minus 6. So my zeros are at t equals 0 and t equals 6. So thinking about this sign chart, I would have a 0 at 0. That's the end of my interval anyway. A 0 at 6, and then I know my interval stops at 10. So plugging in a value between 0 and 6, I have, plug in 1. So this would be 1 times negative 5, so that's negative. And plugging in a value greater than 6, I would have a positive and a positive right there. So already I can kind of tell when it's furthest to the left. Here it's going all the way to the left, right? That's a minimum. And then it's going all the way to the right. There's no other minimums. So I can make that argument, or you could actually plug in and get some values. So two options. You could either say here, it's furthest left at x equals 6. And it doesn't ask for explanation here, so you don't need to give it. But what I would say is because v of t is strictly negative, on 0 to 6 and strictly positive on 6 to 10. That is one explanation. The other explanation would be to do a candidate test. So to think about your endpoints, 0 and 10, your critical value of 6, and then to actually integrate there. So if we think about the integral from 0 to 0 of v of t, the integral from 0 to 6 of v of t, and the integral from 0 to 10 of v of t. And you could also justify the absolute minimum that way. But either of these would work. Okay. Next one says, when is the velocity increasing the fastest? So think about this. Velocity increasing is acceleration, right? And the fastest means we want it to be at a maximum. So I want the maximum acceleration here. So first let's find our acceleration. Velocity was t cubed minus 6t squared. So v of t is t cubed minus 6t squared. V prime of t, which is a of t, is 3t squared minus 12t. So yes, you could say that's a of t, but you have to define that. So I want to maximize this. So I'm going to take a derivative of it and find the maximum. So v double prime of t is 6t minus 12. So that has a critical value at t equals 2. And so what happens there? At 2, we're going from 0 to 10. If I plug in a value less than 2, I get a negative. If I plug in a value greater than 2, I get a positive. So let's think about this. This is a very similar argument to what we did before. This is going to be decreasing everywhere to there, increasing everywhere to there. So logically, where should it be increasing the fastest, or where should the maximum be? The max should be at x equals 10, right? That's the end of our interval. That is where our maximum would be. Okay, probably just going to do one more. This is calculator active. So the velocity moving along the x-axis is given by this on 0 to 6.5. This is your initial position, -1. You guys can't see that. Write an expression for the position at any time. You're given velocity. You want position. Go backwards. Initial plus net change. So my initial here is -1. My net change is from your t values, so 0 to t. And I want to have a different variable in here because t is my unknown time. So I'm just going to replace this with another variable. I just put an x in there. T is my unknown time, so replace that with another variable. All right. Determine when the particle is furthest from the origin. So this is going to be the same kind of thing. We're going to look at the absolute max min position. So I'm going to find my critical values, plug those into my calculator, plug the function in my calculator and look at it. And I'm going from 0 to 6.5. So let's see what my critical values actually are here. So I'm going to graph this. So it's y equals x to the 0.5 cosine of x, making sure that I'm in radian mode. And I'm going from 0 to 6.5. There's what that comes out to look like. So I see 2 zeros. So I see 2 critical values. So I'm going to find those. Second calc 0. So finding the first one. I know it's riveting to watch me use a calculator on a live stream. Is going to be 1. Hold on a sec. Five, 7, 0. And the other one, second calc 0, is, I'm going to do the same thing. So exciting, I know. 4.712. And I'm going to test those values. So to test them, to actually find the position, I'm going to do the initial, which was -1, plus the integral from 0 to 0 of v of t, or v of x, doesn't matter, This one, I'm going to do -1 plus the integral from 0 to 1.570 v of t. This one, I'm going to do -1 plus the integral from 0 to 4.712 of v of t. And this one, I'm going to do the integral of -1 plus the integral from 6.5 v of t dt. And I would look for which one is the furthest from the origin, and that would be my answer. And then when the particle is furthest from the origin, is velocity increasing or decreasing? So what I would do there is when I get the answer to part B, is velocity increasing or decreasing? Well, I would find the acceleration, v prime, right, of answer to part B. And I promise you guys I would keep this to no more than 45 minutes. So we're going to stop there. If you have questions, I'm going to hang out for a little while. But particle motion, again, is going to show up. These are, we went from hard to kind of much, or easy to much more difficult. But you'll definitely see it. Send me questions. We can continue to work on stuff. And I'll hang out for a few minutes. Thank you for watching.